All right. So welcome everybody to our December edition of our Office CTO Hours. I'm joined by Andy Pernsteiner today. This is something we do every month, and it is a format where we want you to ask questions. So use that Q&A button to ask questions, and we will get into the topic. So we decided to do something a little different this month. We decided to talk about, kind of zoom out and do more of a general talk about what we see as our vision for the future with our vast data platform. We had a pretty big announcement this week, but go ahead and advance the slides. First, we'll do introductions. I'm Steve Perchewski. I'm the Director of Product Marketing here at Vast, and I'm joined by Andy Pernsteiner, our CTO. Andy, do you want to introduce yourself?
Andy Pernsteiner, CTO for Vast. Excited to talk with everyone today.
Excellent. So Andy talks to customers all the time. He has a kind of deep vision into this. He can answer any question. So again, don't hold back. These are the most fun when we have interaction. So again, this is our agenda. And again, use that Q&A button, right? I'll see your question. I'll ask Andy and we'll jump into those topics. So the reason we decided to kind of come back and do more of an introductory session is because of our big announcement this past week. We announced a new round of funding. Our valuation has gone triple to almost almost triple to $9.1 billion. I mean, it's just, phenomenal what we've seen in the market. Andy, anything like, you talk with customers all the time, any kind of, is it expected? You were in New York too, right? So you're actually here for this announcement. That was pretty cool.
Yeah, no, it was an exciting time for us. And, it's been an interesting journey. I've been here almost 6 years now, and the accelerated growth that we've had is pretty astounding. And the feedback we've gotten from our customers, our partners, our investment community has been amazing. And so it's really just in some ways the beginning for us as we start to bring our data platform to market in a much more broad way. And this is a good validation of our strategy.
Yeah, I think that's a great point. We were really focused at the beginning on kind of these massive customers with big, huge data sets. And we're seeing that like everybody needs that now, which is kind of really interesting. I know you're going to cover that more, so I don't want to take away your thunder. So one other thing we did this summer was we kind of made this announcement about a data platform. And it was really our vision of the future, where we're going. And it's a term that gets used a lot, right? So like everybody talks about the data platform. And so what we're kind of curious is to know, like, what does the data platform mean to you? Andy, any kind of flavor to add to this before, as people are answering this question?
Well, I think you covered it, Steve, but there's a lot of companies, there's a lot of technologies out there that are basically touting themselves as a data platform. And to be honest, it's kind of a generic word or a generic phrase. And so I think that it's important to understand, as you embark on your journey to process and analyze massive amounts of data, how you look at a data platform may be different than how others do. So it's very interesting for us to know.
Yeah, I'm seeing these responses coming in, and I do want to thank everybody. I saw D jump out. Wait, I put that on there to be fun, and like my fear was everyone was just going to pick that and let that go. But I'm so glad that you're all at least picking multiple things so we can have a good discussion here. So let's go ahead and share that. Can you see the results being shared on the screen now? I think so.
I see results coming in, yes.
We see the results. We see them coming in. Want to go ahead and look at those. Is this about what you expected, Andy? Is this, what you're hearing from our customers?
Well, it's a pretty even split, to be honest, between a number of choices. So it helps for us to validate and see where people are at. It also helps for us to validate our vision, where we're going.
Yeah, agreed. So let's go ahead and look at the next one. You should have done all the above. Yeah, that would be a good one too. All right, so what is our vision for the data platform? Actually, did we not share the results? We share the results. We did that. Okay, so I'm going to stop sharing those. So Andy, let's talk about our vision for the data platform.
Okay. So I think that, and honestly, actually, Steve, it might be easier if I just share my slides, and then that way, simpler for me to go through this.
I'm going to stop sharing mine. That's right.
Great. 1 second, and I will share my screen. Steve, I can't share.
You can't share? Well,
yeah, maybe.
Just share. No problem. I'll just go ahead and share my screen.
Sorry about that.
And just
we can go
tell
me
when to go.
Fine. Yeah.
Cool. All right. I got to click the share button. There we go.
Okay. So when we think about a data platform, Honestly, there's a lot of different components, and we try to simplify as much as possible. But what we found is that generally speaking, you need to store large amounts of data, both structured and unstructured data, because of course, many of the raw assets and data being generated in the world today starts out in an unstructured form. But to do anything interesting with it, oftentimes you have to derive structure from it. And so because of that, a platform needs to include the ability to store and protect data of all different types. And in order to do that, one would need a general purpose storage platform that can store unstructured data, but then also a database storage platform to store structured records in the form of columns and rows and other sort of entities. But then once you have this data, you need to do something with it, of course. And in order to do that, you need to compute. And compute can range among a variety of things. There can be batch-oriented analytics run against data sets that are historical. It can be real-time analytics against new data coming in. It can be deep learning, where large amounts of data are being trained against to build models. And then also inference, which is, of course, required to be able to understand new data that's coming in and be able to act on it. And so all of these things sort of combine together to be able to allow people to process and analyze data at scale. And it's difficult to assemble such a data platform. There hasn't been truly a unified platform that has been emerged over the last several years. And so we're focused on this area because we think it's valuable for customers, because of course, who wouldn't want to have something that they could do all in one place? And so that's kind of where we focus. And so you can hit the next slide, Steve.
Yeah, I think that's a good segue to kind of think like, there are different approaches to data platforms. So I like this slide that it kind of helps, say where we started versus where the others started. So I'll let you go on this one, but it's one I like.
Great. Yeah. So now there's a couple forerunners or front runners, I guess you could say, that come to mind when you think about data platforms. And oftentimes in that market, we found that the players that are focused on building a data platform has largely been focused on building data platforms for more structured analysis. And so if you think about the evolution of big data, if you go back in time a bit, you go back to the era of Hadoop, the idea behind big data, of course, is to collect large amounts of structured and semi-structured data and be able to run large-scale analysis on it. It emerged out of some of the hyperscalers, Yahoo, Facebook, et cetera, and they really found a way to take large amounts of semi-structured data, log data, telemetry data, and harness the power of many machines to do that analytics. And the evolution of that was, of course, the emergence of newer technologies. In the case of Databricks, they basically brought Spark to market and were able to build a cloud-based offering to allow people to use it at large scale. And Snowflake took advantage of the ability to scale flexibly in the cloud to give people the ability to deploy data warehouses and databases without needing to spin up infrastructure. But it's all very focused on structured analytics. And while there are the ability to deal with unstructured data, it doesn't necessarily handle the wave that's hitting us right now, which is deep learning and generative AI. And so when we were building a company, we didn't necessarily know exactly where everything was headed, but we did know that the large scale processing of data would need to be done in a way that was not able to be done previously. And so as we look at deep learning, especially this year, of course, has been sort of the year of the large language model. As we see this as an emerging theme, we realized that the existing infrastructure just couldn't keep up. And so thankfully, when we were designing our architecture, we thought of this large scale amount of processing, and we thought about this large scale amount of data that needed to be analyzed at speed. And we built an architecture to be able to handle it. If you can go to the next slide, Steve.
Yep.
And so our vision has basically remained the same for the last several years. And when I started working here in 2018, so prior to us launching our first product, when I spoke with our CEO and founder, Renan, I basically told him I never wanted to work for a storage company again. And so he assured me, of course, that we were moving beyond it, and shared with me the vision. And so at the time we said, okay, let's start at a foundational layer where we know that there's extreme amount of need. And so phase one of our journey through building this platform has been to build the data foundation for AI. And initially that began as a large scalable storage layer for unstructured data to be stored in a way that allowed for customers to do processing and analytics at scale without sacrificing performance or without having to build their own complex systems to handle this. And that's really where we began. And part of the reason we began there is because it's a hard problem to solve. Building out a way to share data amongst large numbers of applications at massive scale, meaning petabytes to exabytes worth of scale, that's not an easy feat to accomplish. And so
Yep.
by solving a very difficult problem early on, we were able to solidify ourselves in the market as a company who would provide lasting value. Because again, it's always about solving very hard problems and finding a way to make them appear easy. And so that's
Right.
what we initially did with our data store. I don't know, Steve, if you had something you wanted to say.
I was just saying, like, kind of when we started, I think we had to pick these really large customers because some of the customers weren't at the point where they were feeling this pain yet. So we really had to go out there and find those customers. And for them, that's why they were willing to take a risk on a new company, right? I think starting like, we're asking you to trust us with your most valuable assets. And that's why I think like quant traders, like you look at kind of early adopters, it's, HPC and quant traders. And just as we go through this stack, you see it applying to more and more customers. I think that's kind of an interesting journey. I'll let you keep going there, but yeah, I like that.
Sure, great. And over time, as we built our customer base and as we started handling large scalable amounts of data, we started seeing patterns emerge and realized that it was time for us to introduce the next phase, which is effectively our own scalable database layer that exists within our platform. And so it was really done in a way that ensured that we took full advantage of the architecture, which I will describe our architecture shortly, in such a way that we can allow for not only scalable storing of unstructured data, so files and objects, but also large scale and high performance storing of structured data in the form of rows and columns. And so this really puts us in a place where a customer doesn't need to choose between different platforms in order to store data of all different types. And because of the way the architecture is designed, they get the most value out of any hardware or cloud spend that they have to do. And so it really gives them a place where it's efficient, it's cost effective, it's highly performant and scalable, and it can meet the next needs that they might have. And the other thing that we did this year was we initialized our ability to bring our product and our software not only into customer data centers, but also into the public cloud. And not only that, to also stitch together multiple systems, be they on-prem or in the cloud, into a global namespace, which is important as you try to build out a data platform, because it isn't as if all of your data and all of your users exist in the same physical locality. It isn't as if the data that you generate in one location doesn't need to be analyzed and potentially viewed in another. And so creating a global namespace is important in making sure that you can analyze and process data without having to worry about where it was generated, collected, or initially processed. And as we go forward into the future, we'll give little hints into what we're building next. Our next phase in this, which is going to be coming out in the early part of next year, which I guess is right around the corner,
Right.
is our data engine, which is effectively a way for us to start allowing for processing directly on the platform in a managed, cohesive way. And the real goal behind all of what we're building is to build a platform where people can do advanced analytics, deep learning, machine learning, and be able to really have what we consider to be a thinking machine where data comes in and insights come out. And so in order to do that, we of course had to start at the bottom layer and work our way up. And we're going to go through the architecture and how we built that as we go ahead. Go ahead, Steve.
Yeah. So I think kind of the next part is here for every customer, there's, kind of like a challenge that they're concerned about. And so we wanted to ask you, like, from your experience, what do you think is going to be the hardest? So we've got, kind of this poll here. I don't know, Andy, as these come in, what are you hearing? And we were seeing people doing this, right? So this is what we're actually helping customers do. Like, what's the main driver when you talk to people, given that like we feel we do a good job of all these things?
Well, I think that the reason we put the poll question here is honestly because we have such a wide variety of customers that we speak with now. They all have different challenges, but they all end up revolving around the same basic problem, which is in order to store and process large amounts of data at scale in a resilient way that is easy to manage, that's hard to do. Now, there's different facets of it, which might be more challenging for different organizations. For example, organizations who are accustomed to collecting large amounts of data, but maybe not processing it, it's not as
Mhm.
hard for them to imagine managing petabytes or even exabytes worth of data. But for those of which that are very accustomed to processing data, maybe at smaller scale, they could manage their own compute farms, they could manage their own pipelines, but then the thought of managing so much data is a large effort for them to consider. And so we're trying to bring together as many of technology's best parts as possible so that people don't have to worry about the aspects that they're not familiar with. Because it's not as if any individual organization is going to be strong at everything. And so we really want
Right.
to give them the platform and tools so that they can overcome whatever challenges they have without having to sacrifice something.
I think it makes sense. So I actually got a really good question here. So the question is, what role can your platform play in a traditional HPC facility or system? How is it different from those based on GPFS or similar technologies in terms of performance and features? Do you want to cover that one now, or does that like segue really nicely into kind of the next one where we talk about some of the challenges or some of our journeys?
Yeah, so I think I will cover this question. I think
Okay.
if I cover it now, it'll give too many hints on what we're about to cover, but I will definitely cover this. It's very common in our, I would say it's very common in our customer base for
Yeah.
them to be migrating off of GPFS or like technologies over to VAST. And there are some specific reasons why, and I can cover those as we go through the architecture.
Right. Makes sense. All right. So let's start with kind of like, how we started building this. Where did we start?
Yeah, so I think that the challenge that we had to solve at first was there were a lot of people out there who were storing large amounts of data, but they were doing so in a way that was cost optimized, and the sacrifice that they had to make was for performance. So, for example, oftentimes when data was ingested, it would land on a high performance tier of storage. And over time, as that data aged, it would have to be migrated or tiered down to some lower cost form of storage, which oftentimes was something that was also much less performant. And so we found that there was a huge bottleneck in terms of analysis because data constantly had to be moved back and forth between these tiers. And ultimately, for people who were managing these environments, it was hard because they had to manage that movement. They had to explain to their users why data which lived on tier two was slower than data on tier one. And of course, nobody wants anything on tier two. They always want it somewhere that's fast. And it's not just a matter of preference, it's a matter of being able to iterate on their experimentation, being able to iterate on their research, being able to iterate on getting insight out of that data. The longer you have to wait for a result, the more likely it is that you'll give up or move on to something else, and you'll never get the full value out of that data. So our first goal was to solve the problem where people were tiering data. And in order to do that, we created an all flash-based architecture, which I'll explain in a moment. But we really needed to solve that problem of performance at scale, and it gave us a good platform to start with. And so, speaking of HPC, as the person who asked the question asked, our initial sort of toe in the water, as it were, in terms of implementing our platform, was to take our systems and put them into the largest HPC environments that we could find. In fact, my first day on the job, as it were, was installing an alpha system in NASA's Ames facility in California so they could take their 10,000 CPU server farm and
Mhm.
use it to beat up our system. Effectively, we wanted them to find the holes. We wanted them to find where it fell over. And so that's really where we started our journey. And if we think about all of the initial customers that we had, a lot of them were in the high performance compute space where they had existing storage systems, typically GPFS, Lustre, or those
Yep.
sorts of parallel file systems. And they had challenges in terms of scale and in terms of management, but they also had challenges because there were trade-offs when they had to move data between different tiers and they just weren't getting the performance that their researchers required. And so we started our life there, which was to take a platform and put it in the most demanding high performance environments in the world and make sure that it was stable and performant and make sure that it scaled. And that was where we started our journey. But that's only the beginning of things, because as we've found, the HPC market is actually a niche of the world. It isn't broad. It isn't the environment that most people are familiar with. In fact, many of the customers that we deploy to, they aren't household names necessarily. And so we wanted to move beyond that, of course, because once we built a rock solid platform that could withstand all of the load that was being thrown at us from all of these high performance environments, we needed to extend our functionality to allow for more people to take advantage of it. You want to hit the next slide, Steve?
There we go.
And in order to do that, we needed to layer on a lot of features. So parallel file systems, while they have been around for quite some time and do supply high performance storage for a lot of different HPC style customers, they don't really have much fit and finish on top in terms of making sure that they're ready for enterprises to deploy them, even at small scale. And so in order to solve this, what we needed to do was implement all of the features that enterprises were accustomed to. And so when you think about what these features might be, think about enterprise authentication with Active Directory and LDAP. Think about high security environments that require encryption at rest, as well as encryption over the wire. Think about data protection strategies such as snapshots, replication. Think about controls like quotas. And so these are the types of things that we had to implement, and we did so in a way that the enterprise customers were accustomed to. So it's not as if we just did the minimum or lowest common denominator feature set to put on top of our platform. We went and looked at the best of breed technologies that people were already using in the enterprise and made sure that our feature sets were as good or better than what we could find in the market today. And so because of that, you have this highly scalable, bulletproof platform, and now it has layers to allow for it to participate in enterprise environments, which really started to open things up for us in terms of more broad adoption in the market. But as we found, that was just another stopping point. Go ahead, Steve.
Yeah. So I was gonna add one more, and I was gonna say simplicity, right? Because we've seen this start off, say, at major universities where they start off in the HPC lab, and then it gets extended out to like enterprise file and to other things. And it's because it's simple, right? There's no tuning, there's no downtime. You can actually run this. So it doesn't have to be like a kind of a science project, right? It's like, I'm going to set this up and run it. It's nonstop operations. I think that's another huge enterprise feature that people just took for granted that they couldn't have with something like GPFS. Like the cost of that performance was just, complexity. So I'll hit the next one
and
here.
And it's funny actually, and I'll go into the multi-tenancy thing in a minute, which is that I often overlook simplicity because it's just something I'm so accustomed to when working with our customers who are deploying VAST. The ability to do non-disruptive upgrades of the platform, the ability to easily add capacity, expand performance, all of these things I just take for granted because I'm so used to them. And I just kind of assume that they're table stakes for anybody. But it is important to point out that a lot of systems out there that were designed for performance and scale are not easy to manage. And so that was also a very key component of how we brought this to a larger market. And what we found is once we had the enterprise feature sets, once we had the ability to scale in the enterprise as well as in the HPC environments, what was next for us? And what we've been finding is that increasingly, both large scale hyperscalers as well as even enterprises and new upcoming startups are starting to act more like cloud service providers. And so even within a general purpose organization, they're building their own internal clouds to allow for different departments or different consumers or their own customers to be able to take advantage of their service offerings. And so for us to be able to be a suitable choice, we needed to start building features into the platform, which allowed for it to be shared across hundreds or even thousands of different tenants within a single organization. And so luckily, we had initially built the platform to service multi-tenant workloads, but we didn't expose them all initially. In fact, when we first released our product, we had multiple tenants, but we used them for internal purposes to keep monitoring separate from customer-facing I/O and that sort of thing. So it was very easy for us to add multi-tenancy features. And the way that we add everything is we basically go to our customer base and ask them what they need. And so some of our largest customers over the last year or so really come to us saying that the most important thing for them is secure sharing of their space to multiple consumers in such a way that they can ensure that each one of them gets a fair slice of the pie, as it were. And so features like quality of service, features like external key management for individual encryption keys per tenant, those are the sorts of things that were required, and those are the things that we've been delivering this year.
Yeah, it's kind of interesting. We've actually kind of become like almost the de facto choice for these new GPU cloud providers, and we're going to cover that in another slide. There's 2 questions in the queue. I'm actually going to hold them because they just work great with slides that are coming up. So stay tuned. We are going to get those questions and keep asking them. Appreciate it.
Great.
So let's talk about that architecture.
Sure. And so this is a very high level abstracted view of how we see our architecture. And when we first built out our platform, we needed to design something that was new. There wasn't an existing paradigm that we could use because there were challenges with all of them. Now, I won't go into all the details behind shared nothing architectures versus shared everything. But we really coined the phrase disaggregated shared everything. And the basis is pretty simple. Effectively, in order to store large amounts of data, you need to store it somewhere. And in order to do so on Flash, you need a lot of Flash devices. But what we found is that there's advantage in taking the actual storage layer and separating it from the layer that handles the management of that storage, separately from the compute that manages that storage, maybe is a better way to say it. And so what we did is we took all of the state layer and we moved it down into separate devices in such a way that those devices or those enclosures did not have any responsibility for the formation of a system or the management or the protection of it. All of that was offloaded to stateless containers that run on separate servers. Now, this is regardless of whether it's deployed on-prem or in the public cloud. We create this separation between logic and state, and there's a lot of advantages that we get from it. The first of which is that we don't care what happens for the most part if any of the compute layer servers fail, because they don't own any data. All data that is ingested into the platform is immediately persisted down to persistent media that lives in other devices. And in order to do this, we had to create an architecture called disaggregated shared everything, where every one of the containers up above is able to see and address and directly manipulate any of the Flash media that's down below. And so what this also means is that those containers up above do not need to consult with each other before performing some type of transaction. And this is important because as you scale, limiting of east-west traffic means that you don't have to worry about any sort of contention when there's a large amount of I/O or a large amount of processing or a large amount of transactions happening at the same time. Each of those containers operates as its own entity, but is able to share all of the data down below with all of the others. And so this is a very unique architecture. We basically brought it to market. We're the only platform to bring such an approach to market today. And it's given us a lot of other advantages. Another interesting thing that it gives us is that we can scale performance independent of capacity. And for those of you that understand storage, and especially spinning media versus SSDs, what you'll find is that the bottleneck in terms of performance for a Flash-based architecture is such that the performance is never bottlenecked by the media. The performance is almost always bottlenecked by the CPU that needs to address and manage it. And so by decoupling those two, we can allow for the scaling of performance in such a way that you can get more performance out of your media just by scaling compute. But you don't need to unless you need to, right? And so what that means is that we aren't forcing you to scale them at the same time, which ultimately our goal is to make everything cost effective so that you can deploy as much as possible at scale. And so a part of doing that is to give more flexibility by allowing you to separate how you scale those different types of things.
We just did like
I can go on. Yeah, go ahead.
Yeah, I was just going to jump in and say we just did kind of a review of a wide array of systems. It was interesting to see you had some customers that had like 20 compute nodes to 70 D boxes, where so they needed more compute, they needed more storage and less compute. And then you see some of their systems that are totally flipped, where it's a lot of compute and not that much storage. So it's really interesting. So I did want to ask, there's a question about data protection. And we're able to do some really interesting things because we're relying on kind of the attributes of Flash for data protection. So the question is from Alex is, have you considered backing up all that data, right? And that's a huge thing. Once you get into, like an exabyte of data, how do you protect it? He's asking, what's our solution for
Sure,
the backup
sure.
challenge?
There are multiple approaches to backing up a large amount of data. Now, obviously, not every piece of data needs to be backed up. A lot of it is ephemeral, temporal data, so it's not necessarily needed to be backed up. And oftentimes, we find ourselves in environments where there is a layer of what a customer is storing that doesn't need to be backed up. But in many cases, that there is a need. Now, there's a few strategies. One basic one is it depends on what you're protecting against, right? So if you're protecting against somebody accidentally deleting, or if you're protecting against ransomware, there are snapshots, including immutable snapshot capabilities built into the platform today. But if you're worried about what happens if, let's say, an entire data center or region in a cloud data center catches on fire,
Mm-hmm.
and you need to make sure that your data is somewhere else and safe, there's a few strategies. The first strategy is that you can deploy another VAST system in another location and allow for our native replication to efficiently copy and move data from place to place on a scheduled basis. And so that's something that customers are using today. But you have to consider, of course, that many times people don't want to pay twice for the same data, right? They'd rather have
Right.
a much lower cost for that backup. And so we've worked with a couple different backup vendors to allow them to take data on our system and then ingest it into their own backup platforms. And we have a list of certified vendors that we've worked with who do this. But there's another way that this can happen, and the target for those backup applications can often be, let's say, the public cloud, which could ultimately be
Right.
something like AWS S3 Glacier or some other very low-cost media. There is another option that's built into the platform, which is that we can replicate and back up any data on the platform to any S3 compliant object store. It doesn't need to be Amazon. It could even be one that's on-prem, that's deployed by yourself. And in this way, you can have a backup copy of data that can be accessed when you need it, in case of an actual disaster. So there are multiple approaches to data protection, and it just sort of depends on the use case and why you're protecting that data.
Yeah, that makes sense. And there's so much to get into. Like, I love our vast catalog, which helps you really get visualization into that data, and you could make different decisions there about what you're protecting. But we got to keep moving, and there are some good questions popping up here that are just going to work great with what you've got coming up next. So I want to move on to the next slide.
Great. So it looks like someone did ask about protocols. So let me start with the fact that when we take our disaggregated architecture, at the bottom layer is where data is stored. And so from 2019 through 2022, what you could store on the platform were files that could come in over NFS, SMB, or they could be objects, which came in over the S3 API. I noticed that Sam had asked whether we're S3 compliant with gRPC, et cetera. The S3 implementation that we have done covers almost all of the AWS S3 semantics in terms of API compatibility. There are always some that we aren't going to support based on the fact that we are a system as opposed to part of the overall Amazon ecosystem. But for the most part, everything that AWS S3 supports, we also support. It does provide some compatibility layers, obviously, for using GS utils and other tools that might be present in other cloud providers. And the way that we treat data is that we don't differentiate between files and objects. So data that comes in over one API or protocol can be accessed over another. So data can be ingested over NFS and read over S3 or SMB, or vice versa. And so this provides a lot of flexibility when it comes to creating an environment where multiple applications, which might have different requirements, that they can all participate and analyze the same data together without having to make extra copies of that data. In addition to supporting unstructured storage APIs like NFS, SMB, and S3, we also support what we would consider to be more application storage interfaces. And the first that we released several years ago was a CSI driver that integrates both in Kubernetes and OpenShift to allow customers to deploy persistent volumes on the platform in a more automated fashion. So the plugin allows for automatic creation of quotas and snapshots and makes it very easy for people to deploy Kubernetes and other containerized environments where all their persistent volumes live directly on VAST, so they don't have to purchase a different layer of storage to handle that. And something that we're going to be announcing over the next couple of months is support for a block level interface using NVMe over TCP, which further allow us to provide to both customers and cloud service providers the ability to offer services such as block level storage for applications that require it, as well as for, let's say, boot operating systems for server farms. So these are all what I would consider to be sort of unstructured and application level structured storage, which is sort of, we'll call it run of the mill for what a storage vendor would provide. But what we wanted to do is make sure that this platform continued to expand and extend its reach into more and more environments. And to do that, we needed to cover another type of storage, which you hit the next button on the slide, Steve. I'll talk about what that means. And so in 2022, actually, we announced this, but in 2023, we actually launched it into GA software, which is support for our own native table format. And the initial target was primarily for large-scale data lake migration. So people who were accustomed to using Hadoop-style analytics tools, such as Spark or Trino or Dremio, these are open source tool sets that people are using to analyze large amounts of data, structured and semi-structured data at scale. And we found that the bottleneck in many cases was the way that the underlying storage layers were composed. And so we found a better way, which is effectively to create a database format that allows for those execution engines, which they, again, it could be Spark, Trino, Dremio, and the list goes on. But as they run their queries, they can offload a lot of that work to us so that we can do the internal filtering and then only return the results back to them. And so this really extends ourselves to be able to not only support unstructured workflows, but then also to support large-scale analytics and large-scale streaming ingestion on the platform for structured data as well. So again, you don't have to choose between sort of different places to put things. I don't know, Steve, you want to go and hit the next button?
Yeah, and there's a couple questions coming up that I want to cover on this slide, but go ahead and launch into it, and then I'll share those questions that are in the chat.
Yeah, and so if you kind of look at our architecture and you move it along a little bit, most of what I've covered so far is what we call the data store, if you look off to the left. And primarily, it's been used for enterprises and HPC environments to store large amounts of unstructured data. And we're seeing increasing demand in the world of generative AI for large amounts of unstructured data as well. And one of the key ways that we've integrated in that fashion is that we are NVIDIA Superpod certified, which means that if you are deploying a Superpod or a series of NVIDIA GPUs, we have certification with them. And one of the reasons we have this certification is because we have integrated with their high performance transport mechanism known as GPU direct storage, which basically allows for much higher bandwidth between the GPU server and the storage layer to bring access much faster and faster so that the iterations that they do can happen more quickly. We could go into all of that detail at some point, but go ahead.
So actually, I want to ask, since you mentioned Superpod, there's actually a question about Superpod down below. And again, I'm doing these out of order to kind of go in, but the question was from Jens, and he asked, is there any plan to be certified with Ethernet for DGX Superpod? Because we did it with InfiniBand, correct?
We did it with InfiniBand. And so the irony of some of this is that many of the Superpod deployments that we're being put into are Ethernet based. And right. So it's under discussion. It's just another test iteration. Just for background, we have supported both Ethernet and InfiniBand for customer connectivity since our inception. So our initial deployment into NASA that I mentioned earlier, our initial deployments into NIH, those were InfiniBand. But Ethernet was where we felt like we were going to focus most of our energies for enterprise customers. And so we can actually allow for a single platform to not only interface with Ethernet, but also InfiniBand at the same time for the same data. And so what this enables for Superpod deployments is that oftentimes NVIDIA is kind of focusing people on using InfiniBand for the GPU layer so that the GPUs have a low latency fabric to talk on. We can support talking to GPUs over InfiniBand, and we can support also the ingestion of data over Ethernet from the rest of a customer's environment, because oftentimes, especially enterprise customers, they don't have InfiniBand environments in the rest of their world. It's all Ethernet based. So being able to have a system that can talk to both means that it's very easy for people to ingest data and then process without having to make extra copies or shuttle it between different environments. And so kind of to carry on, if we want to talk about the database, the database is just an extension of the platform. Everything sort of sits alongside each other. It's not as if we stacked it on top of other layers. And so it's a very much first-class citizen, as it were, in terms of being able to offer the best performance and best flexibility and scalability that the rest of the platform offers. And then if we look at where we're going with this, the data engine, which we're announcing, but we haven't implemented yet in terms of shipping to customers, is going to be a layer that allow people to do functions and processing directly on top of data that lives both in unstructured data as well as in the structured tables on the platform. And we put Python and Kafka on this list because those are some of the first sort of forays into it. But really, we're trying to offer a more flexible compute layer that is managed and is tightly integrated and woven with the rest of the platform so that people can deploy functions, people can deploy applications, people can deploy containers, and they can deploy pipelines directly on the platform without having to manage a bunch of other things. And stitching all of this together across a global namespace is also part of our strategy. And so what we've done this year is allow for people to not only deploy it in a data center of their own choosing, but also in the public cloud and then at the edge, right? So when we talk about the edge, we're talking about a much smaller sort of capacity footprint, but then also participating with the greater whole. And so we have a lot of flexibility now. If you go back, let's say 4 years ago, it was pretty limited in terms of where you could deploy VAST. But today, there are basically no environments where we can't be deployed because we have such support for a large variety of offerings. And our software has been updated to be very flexible in this nature.
So there's a question here, kind of a data platform question. It's about GPUs. So it says, is VAST providing its own GPUs, or are you aggregating or even white labeling the underlying hardware providers and or cloud providers? And so I think that kind of dovetailed really well into what you're just talking about, right? So, across edge, core, and cloud, we've got kind of different certified solutions. But I wonder, is that something you want to elaborate on? Like, we're not providing the GPUs, but through the data engine, we're kind of optimizing how you use them and like even integrating with some schedulers that kind of help here.
Sure. Yeah. So I think what our strategy is always to, honestly, to perform the least amount of work and get the most amount of leverage, right? And so the way that we've done that in terms of GPUs is we've partnered with and become the platform of choice for a number of newer cloud service providers. So at the lower right-hand side, you see CoreWeave, Lambda, and Core42. Those are all cloud service providers who are very focused on providing large-scale GPU farms to customers in the same way that you might go to AWS and rent EC2 instances to be able to do CPU processing. Those new cloud providers are focused exclusively on GPUs and building out their networks and the rest of their infrastructure for high performance. And so we partner directly with them so that they can offer our storage layer and database layer services upstream to their consumers. And as we build out the functionality of the data engine, they will also be able to leverage that and offer it upstream to their customers as well. So we aren't providing GPUs, but we are powering a lot of the cloud service providers that are leveraging lots of GPUs and giving them services that are optimized for their GPU investments. And for customers who are deploying their own GPUs, we also offer a platform that gives them the best possible value. Because the name of the game when you buy or rent GPUs is to make sure it's busy all the time, but that it's busy all the time doing the right things. And so that's part of what GPU direct storage is about, which is to accelerate data to move from a server into a GPU's memory, but not to waste the GPU's cycles on doing that movement. So GPU direct storage offloads all of the work to the network card so that when data is moved into the memory of the GPU, it can be processed immediately and doesn't require any additional steps or movement through the CPU complex. So that's really sort of where we focused is let's get it to the point where GPUs are optimized as much as possible and they're getting used as much as possible.
Makes sense. So let's jump into our bigger vision with the data space. I think this is, there's a couple of questions that are going to tee into this as well. So I like where we're going with questions.
Definitely.
Keep it coming.
Yeah. So, and I've already covered this to some extent, but the whole idea behind a data namespace, or in our case, we call it the data space, is to be able to make sure that when data is ingested, it's immediately accessible and visible to consumers that might be in a different geographical location. And ideally, the consumers in those other locations aren't even aware that the data isn't in their same geographical place. So if you have data that's ingested in, say, Tokyo, and you have somebody who wants to access or process it, or you have a job that needs to execute against it that might be in a different geographical location, you don't want the user in that other location to know that they have to wait for data to move. And so being able to efficiently move just the bits that are required and do so in an intelligent manner that's very well integrated is important. But a big part of it is the presentation layer, showing to the user that they don't have to move data from place to place. Giving them the same view of data regardless of where they are is important to forming a global namespace. And so we've done that for our protocol and database layers in such a way that you can ingest and you can access and you don't have to worry about where it is. There's a lot of details behind it, but the essence is that you don't have to think about where data is placed anymore. You just have to perform whatever analysis you want.
And so that could help us avoid data movement. So there's a question about egress fees, right? So that's always a concern when using the public cloud, and as we're now starting to extend ourselves in the public cloud. So here's the question. I'm going to read it for you. He says, conceptually, you can have vast data stores distributed globally and then ingest into a hyperscale compute platform, right? And that's exactly what we're going for. Large scale, and then run large scale analytics for training, take the weighted reports back, and then distribute the data within the hyperscale platform so you don't get hit with egress fees. And that's part of
Yes.
what we're looking at, right? It's like the very efficient data movement.
That's so all, it's funny, no matter what fancy technological terms we come up with, everything comes down to time and money. And
right.
honestly, the way that we see it is that, most of the cloud service providers make a significant amount of money in moving data out of their platform. So generally they're incentivizing you to keep it in there as much as possible. But if you can optimize your workloads in such a way that the computing only results in a smaller subset. So, using training is a good example where you take the model weights or you create a model itself. Those things are generally pretty small. The training data might be a much larger data set. You could talk about terabytes or even hundreds of terabytes of data that are trained against, but the output might be model weights or a model that's less than 100 gigabytes in size. And so in those cases, using the cloud where it's best suited, which is to do large scale elastic processing, is really the way to do it. And then to distribute that data back to the edge or back out to the data center, but doing so only for a smaller amount or a smaller subset, that's really the key. So the workflows that we're trying to enable are largely based around that concept of burst computing. And especially as training and inference become more prevalent in organizations, we think that this is a good area for people to optimize on.
It makes sense. So I'm going to pop to the next one. And I think it also there's another question that I'm going to ask you in here, but cover the slide and then I'll pop the question.
Sure. Yeah. Now, whenever you're deciding how to move data, again, it comes down to time and money. And there are situations where it makes sense to move data. There are situations where it makes sense to run the compute directly next to the data. And it really comes down to time and money. It comes down to latency, bandwidth, the amount of I/O, and also the availability of the correct type of CPUs or GPUs in a physical location. So if, let's say, in Tokyo, you don't have any GPUs and you have data that's ingested there, you have to make the trade-off between deciding, do I move all of this data over to, let's say, Los Angeles, or do I buy some GPUs in Tokyo? And there's always going to be a cost trade-off. Now, what we've done is we've created some flexible models and policies to allow people to kind of choose which direction they would lean in. If there's GPU availability in one location and the data doesn't happen to be there, there can be a choice where we can move data in a sort of optimistic fashion, in the sense that we only move the bits that are required and we prefetch ahead of whatever the application is doing to make sure it has what it needs as quickly as possible. Because, at some point you have to decide what's more expensive, having an idle GPU or spending money on movement of data. And there's going to be a place where it makes sense to move data because the GPU cost is so high. And then in other cases, you might want to move the compute to the data, meaning we will inform schedulers on the most optimal place to run their compute jobs if there's available compute or GPUs in a location. So in the case where Tokyo does have some GPUs, there might be a use case for us to tell the scheduler that it's best to run that compute job locally instead of running it in a farm where it might have a larger number of GPUs. So it really is going to depend, but honestly, that's where a more intelligent policy engine, which can inform schedulers, which can inform compute engines what they should do, that's where we're iterating right now and working on.
So there's a question here about, can we span multiple data centers? And how, can we go across regions? And then kind of a question about latency. And that's, part of this is because we don't need to push everything everywhere all the time or wait for syncs at remote sites, that latency becomes less of an issue, especially if we can make intelligent choices about where we want to do what. I think that's kind of, it helps answer that question.
Yeah, I mean, honestly, latency is, we can never completely defeat the laws of physics. But we can plan and we can optimize so that the laws of physics don't apply as much. And so doing so allows us to give people, let's say, the illusion that we've defeated the laws of physics. And a lot of times there is a good enough concept, right? It doesn't have to be perfect. It has to be good enough to make sure that you can continue doing whatever processing you're doing without having latency or geographical distribution as being a barrier.
Right. So let's pop to the next one. Again, we're coming up on time here, but this is, I think, a really important slide. It helps us kind of contrast kind of the legacy way of doing this, right? You certainly could build this on your own, and people have, but it's really difficult. And you wind up bolting together a lot of things. Like a lot of other people are talking about like zero ETL. And because they have to kind of put this glue between all their components. And well, I'm probably stealing your thunder here, but like, because it's all in one system, it's so much simpler. So I don't know if you kind of elaborate on that.
Yeah, I think that when we talk with our customers, we find that they are using a plethora of different technologies, both in their data centers as well as in the public and hybrid cloud environments, where they're stitching together lots of different components and then having to write glue code and move data between them. And that's challenging, right? In the public cloud, oftentimes there is a point solution for every possible application. But they were never really built for the AI era. There are, of course, now service offerings within the cloud providers that are focused on AI, but a lot of the implementations of data warehouses and storage layers that were put into the public cloud didn't really anticipate what was coming in terms of deep learning and inference. And so we've designed a platform that can deal with all of these new types of workloads and not require that people spin up so many different services. Not only that, we're managing all of them. And so the API frameworks and the integration points are all tightly coupled together in such a way that, having data that lives in the, let's say, the object store on the VAST platform means that it automatically has an index and a catalog that can be queried using SQL, right? So some of the features we've announced over this last year are tight integration between our unstructured data store and our structured store in such a way that not only is all the metadata for the system automatically indexed and searchable, but so is all the audit record data on the platform so that you can understand everything that's happening and use tools, especially using SQL, which is a very well understood paradigm, to be able to do that analysis without having to go and write extra glue code to do it.
Makes sense. So as a result, again, we have this slide, and we talked a bit about this already, right? But we are really becoming the de facto kind of operating system for these big GPU cloud providers. These were big announcements we made over the summer. There's actually kind of more in the pipeline. So it is interesting. We're kind of the only thing out there that provides the blend of the performance and scale along with the features that you need to actually slice this up and sell it as a service. And anything you want to add on this slide, or I think the other we'll kind of start wrapping things up and cover a few questions that didn't fit into some of the other categories.
Yeah, I think the big takeaway for this is that, if you are needing to deploy a deep learning or a machine learning strategy, but you don't have the expertise to build out your own GPU server farm with all the advanced networking and storage and pipeline management that you think is necessary, there are options so that you don't have to build it yourself. And we are the back end for many of those options. So at least two of the companies on this screen, you can go and rent GPUs from them, and the backing store will be VAST. And over time, additional service layers will be offered from them that will be VAST based. But this is just a way for people who aren't necessarily going to build out their entire environment to get started and then to scale, right? These are organizations that have hundreds of millions, if not billions of dollars worth of GPUs deployed into data centers throughout the world, and they're offering them to customers who want to rent them.
Makes sense. So this is just, kind of our big customer logo slide. Again, just, what's kind of fascinating is what's good for these service providers, and it's been good for HPC shops, it really has a very wide appeal across many organizations, right? We kind of, essentially skated to where the puck was going to be, understanding that the problems of AI and large data sets were going to be a problem for a lot of customers, and that's part of what's paying off. So let me cover a few more questions here before we move on to the last one. So there's a question here about sync replication. And I think it ties back a bit to some of the options we covered before. So the question is sync replication with an RPO of 0 on the roadmap? Do we have customers asking for that?
It is. So we have had a few customers ask for it because obviously there are technologies that provide it. It depends on use case. We do have it on the plan. I think the time frame is really up to the demand that we see from the customers, right? So oftentimes sync replication is a workaround for something else. And we're really focused on finding out how we solve that something else, because there's a penalty when it comes to sync replication, which is that latency is not your friend. And so while there may be a subset of applications that require it, the majority don't. And so we've focused primarily on the majority that don't, but it is part of the plan for us to deploy something that's very similar in spirit, you could say, to SnapMirror, if you want to think about it that way.
Makes sense. So Sam has a question about the maturity matrix for our Kubernetes and CSI driver. That might be, should we follow up with that one offline, or is that something
that's a follow-up? I have someone on my team. Yeah, I have someone on my team who focuses exclusively on integration with different types of Kubernetes environments. And so both applications as well as versions of Kubernetes and OpenShift and that sort of thing. And so I think that probably the best way is to tackle that one offline.
All right, Sam, we'll get to you. Thanks for the question, though. All right, so again, thank you so much for your questions today. Andy, I think it's a great session. So what we did is we actually engaged with an analyst, Merv Adrian from IT Market Strategy, and he wrote a paper on his kind of view of what our data platform is doing in the market. So if you scan this QR code, you'll get access to that paper. And at the same time, when you visit this, there is a chat window where you can engage with us, right? So if there was a question that you wanted to answer or ask today that you didn't get around to, hit this link and we're going to be glad to help you with that. And so with that, I'm going to go ahead and close it up. Andy, thank you so much for your time. Again, just, it's incredible the kind of the momentum we're achieving here. Again, just, very exciting time to be at Vast, and just exciting to see what our customers are building on top of this.
Yeah, thanks so much. Thanks everyone for joining today.